Good afternoon. In this discussion, I'm going to show that 21n plus 4 divided by 14n plus 3 is irreducible for any arbitrary integer n. This means that the numerator and the denominator are co-prime. So, without further ado, let us begin. We will show that the numerator and denominator are co-prime, meaning that the greatest common divisor between the two of them is the number 1. So, to show this, we're going to take g to be a common factor between the numerator and the denominator, and we need to show that g is the number 1. So suppose g is a common factor of the numerator and the denominator. This means that the numerator can be written as g times some integer a, and the denominator can be written as g times some integer b. Now, if this is going to be correct for any integer n, and n is an arbitrary integer, then what we need to do is we need to get the n's to vanish. So to do this, we're going to take the least common multiple between the coefficients of n, which are 21 and 14. And the least common multiple is the value of 42. So we can rewrite 42 as 21 times 2. And 42 as 14 times 3. So we're going to multiply g times a times 2 and g times b by 3. The reason why is we have identical coefficients on n with the value of 42. So we can subtract those expressions so that the n's will vanish. Okay. So 3 times g times b minus 2 times g times a is the number 1. So indeed, we see here that 1 is equal to g times 3b minus 2a. It follows that g is a divisor of the number 1. And that means that g is indeed 1. So g divides 1 and g is equal to 1. So we know that the greatest common divisor between the numerator and denominator is 1. This means that they're co-prime by definition. So indeed, 21n plus 4 divided by 14n plus 3 is irreducible.